Okay, now we're going to do some statistics. We're going to use the Year 12 book because it's better laid out than the Year 11. I'm going to cover this fairly quickly because it's a repeat of Year 10. And the best way to do it is to see my summary, so I'll bring that up here. This is what we went through in class. First of all, we look at the types of data. Your data, you can have, talk about population and sample. Now the population is the entire group that we are inferring about. So for example, the whole cohort of Victor Harbor High School students. The sample is the small group that we select, gather data to represent the population. So for example, a small group of 30 students. Rather than interview the whole school, we interview a small sample and infer something about the population. Now samples can be either cluster, systematic, convenient or stratified. We won't go into the details of that on the video, but the best sample is a stratified, where you actually select the people in the sample in the same percentage as you would find in the population. For example, Year 8s, you would select more than Year 12 in your sample 30, because in the population the Year 8s have a higher number, high percentage representation. Now, once we select our sample and we collect our data of, say, 30 values, then we need to display it as a graph. And we can display it depending on what sort of data we've collected. Data can be split into numerical or nominal. Numerical is number data, nominal is name data. Numerical can be split into discrete and continuous. Discrete data is things which have fixed divisions or intervals. For example, family size. You could have 1, 2, 3 people, but you couldn't have half a person, so that's called discrete data. An example of continuous data would be something where you have infinite divisions, intervals. Something like height, where you can have 168 or 168.1 or 168.01. There's no limit to the accuracy, so we call it continuous data. Nominal data can be split into categorical and ordinal. Categorical is things like what sort of holiday would you like to go on? Would you like to go skiing or surfing? These are categories that you're asking the person to feedback on your survey in the sample. But if you ask them to rate how much they like a holiday, and you said low, medium, high, then you ask them to give you ordinal data. It's ranked in order. Sometimes the best way obviously is to ask them to rank on a scale how much they like a holiday from 1 to 10. Then you're getting numerical data, discrete numerical data, which you can then plot on a graph. You can see the difference between the graphs. If you use discrete data, then you've got the variable x on the bottom, so that could be family size. Because it's discrete, see how there's gaps between the columns. If it was continuous data, then we have no gaps between the columns, because they're infinite and run into the next category. On the y-axis we always plot the frequency, and these are called histograms when we do that. In categorical data, we place on the bottom axis the names. So in class we had an example of Cocoa Pops and Weet-Bix, and so there's no particular order, we could put them anyway. The problem with that is, see on the left we get a normal distribution where it goes up and then comes down. With categorical data it's random, the order in which you put this. However, in ordinal data there is an order, so it's low, medium, high, and you can still get that normal distribution coming out. And that's really review of year 10. The other next section is looking at the types of averages. From the sample data you can create 3 types of averages: the mean, mode, median. In Year 11 get used to the notation, so we've got x bar being the mean, that's equal to sigma, which is the sum of the individual xi values, all divided by n. So that's the sum of the numbers divided by the number of numbers. That's what the mean is. The mode is the most frequent, and the median is the middle value after you've ranked order it. ordered the numbers. So here's the numbers 1, 1, 2, 2, 3, 3, 3, 5. Then the middle number is between 2 and 3, which is 2.5, and we call that median. Now that occurs at the n plus 1th position. So here we have 2, 4, 6, 8. So 8 plus 1 is 9. 9 divided by 2 is 4.5. So this occurs at the 4.5 position. So it's 1, 2, 3, 4. The 4.5 position is where it lands. Now this should say n plus 1 on 2. So I'll just correct that now. It occurs at the, I'll just fix that up, that should be the n plus 1 on 2 tooth position or value. Now we look at the box plot. We have, for example, these numbers here ranked order. This is the maximum 6, this is the minimum 1, the median is in the middle 3, and if you do the middle of the lower half, which is this set here, then you'll get 2, it's called the lower quartile. If you do the middle of the upper half, you get 4, so we call that the upper quartile. So we split it into quarters, and to put on the box plot, the lower quarter is at 2, so you place the line at 2, lower quartile, upper quartile at 4, place the line there, median at 3, minimum at 1, maximum at 6, and you construct the box plot like that. The red lines represent the outliers. The outliers specify a region where we ignore data if there are extreme scores. If we had a 7, it's ignored. To work out what the outliers are, you use this formula here, x bar plus or minus 1.5 times the IQR. The IQR is the interquartile range, which is the upper quartile minus the lower quartile. In this case it's 4 take 2, which is 2. The range is the max take minimum, which in this case is the 6 take the 1, which is 5. So to work out the outliers, we do the mean, which is 3, plus or minus 1.5 times the IQR, which is your 2. So it's 1.5 times 2. So that's 3 plus 3 and 3 minus 3. So it's 0 and 6. And that's why we put the 2 outlier regions at 0 and 6. That's a very quick summary of Year 10, just to be aware of it. And now we get into the Year 11 section from the Chapter 7. We're going to do the Year 11 part, which is standard deviation, and then go relate that to normal distributions. Now standard deviation is given by this formula here, S, standard deviation, is equal to the square root of the sum, that's sigma, the sum of xi take x bar is the mean of all your data, xi is all the individual values, like the people. So you're working out how far away everyone is from the mean, you're squaring it so that you get rid of negative numbers, and then you square root to get rid of the effect of the squaring. You divide by the number of people minus 1. That's just the rule we mathematicians have applied for the standard deviation of a sample. Now it's best if we see with an example. So look at this worked example here. If you've got these numbers here, 5, 17, 15, 3, 9, 11, they are scores from wholesalers, and the numbers could be numbers of apples there that have blemishes on it or something like that. Now first of all you work out the mean. The mean is worked over here as 60, the total is 60, divided by the 6 numbers, so 60 divided by 6 is 10. So over here in the xi take x bar column, we've got to do 5 take 10 to get minus 5, 17 take 10 to get 7, 15 take 10 to get 5, etc. So that's going from that column to the next column, you subtract 10, then go to the next column, you square it, and then you sum them all up to get 150. That goes into the top line. The sum of the xi take x bar all squared is 150. On the bottom is n take 1, so that's 6 take 1, which is 5. If you square root that, we get 5.48. So the standard deviation is 5.48. Now we need to know what that means. That gives an indication of how spread the data is. The bigger that value, the more widespread the data is. The smaller the number, the narrower it is. And we can apply exact values to the standard deviation by going down to here, the significance of it, and this is the significance. So 68% of the data lies between plus or minus 1 standard deviation, 95% of the data lies between plus and minus 2 standard deviations, and nearly all the data, it's actually 99.7%, lies between plus and minus 3 standard deviations. Now, using an example to see that, you could see with this one here that the x bar is in the middle, and there's x bar plus s, x bar minus s, so you've got 68% lying in that region, 95% in the next region, and then almost all the data in the third region. So for example, if we had a mean, an x bar of 50, and we had a standard deviation of 5, then the mean here is 50. If you add on 5, you get 55. If you take off 5, you get 45. So that means the percentage of people that have values between 45 and 55 is 68%. If this was the apples, so the percentage of bruised apples between 45 and 55 is 68% of them. Then we add on 2 standard deviations. We're going to add on 10 and take off 10. So the next value, that 2 standard deviations, will be 60, and taking off 10 from 50 we'll get down to 40. So that means between 40 and 60 bruised apples there will be 95% of them. And the 3 standard deviations, we add on 15 and take off 15, so this will be up to 65 and down to 35, and between 35 and 65 bruised apples there will be almost 100%, or 99.7% will have between 35 and 65 bruised apples. So that's a specific example of the meaning of standard deviation. Now you can try some of these questions in 7b6, 1, 2 and 3. Pause the video and come back for the solution. And here are the percentages solutions for 7b6, 1, 2 and 3. Okay, now we'll go to normal distributions, which is down in F. And the normal distribution is something which is symmetrical. So this is a symmetrical graph, and that's where we can start applying this standard deviation theory, because we've got our x bar, our mean there, and we can have a plus standard deviation on the right and a minus standard deviation on the left, and we work out percentages in between. So if it's symmetrical like that, we call it normal, as opposed to other distributions that there would be positively skewed, which you would have done last year, and this one here would be called, actually I'll go across like this one here would be called negatively skewed, if that's our y-axis and x-axis. So positively skewed goes to the right, negatively skewed goes to the left. But we'll look at normal distributions where it's symmetrical. Okay, now we could ignore that formula there. The first thing we're going to cover is we've got standard deviation again. We can see the 68% is between plus or minus 1 standard deviation. We now change into, instead of x bar, we used to have x bar as the mean, and then we'd have x bar plus s, x bar plus 2s, etc. Now what we do is, instead of using x bar, we use mu, and instead of s we use sigma. Right, so mu and sigma. That corresponds to here. The X bar was the sample mean, but we're now inferring about the population, so that's the population mean. So this could be the mean of our sample 30 students. This is the mean of the whole school. Likewise, this is the sample standard deviation of the students in our class, whereas this is the population standard deviation of students in the whole school. So because we're inferring about the whole population, we're going to be using mu's and sigmas, but the same rule applies. We've got 68%. Now if you divide that by 2, that means you've got 34% there, 34% there. Likewise, you can get the other percentages doing this similar sort of thing. Okay, so there are some simple questions there, working out percentages. So you can have a go at 1 and 2 and pause the video and come back for the solutions. And here are the solutions: 7F1, question 1 and question 2. Okay, now we're going to look at doing this using a graphics calculator. We can, instead of relying on the 68, 95, 99.7 rule, we can do this using the calculator. So I'll bring up the calculator to show you. So I'll do question 2. We'll look at C and D. So first of all, we need to work out the probability that a student lies between 178 centimetres and 186 centimetres. And the way we do it is we go second distribution, we do normal CDF, which is normal curve and its cumulative distribution function. So normal CDF, the lower value is 178 centimetres, upper value is 186. So put in that value. Now our mean, the mu, it says here is 170. That's the mean. So put in that number, and then we put for the standard deviation, population standard deviation, we've got 8. So put in 8 there, and then go down to paste, press enter, and then enter, and so the answer is 13.6%. So 13.6% of students have heights between 178 and 186 centimetres. If you had to do something like D, less than 162, you can get the same one up going second entry. Now the lower, this time, is to the left of 162. So the maximum value, the upper value is 162, but the lower value we're going to make right to the left, which is minus million billion. So then we say that by putting in a minus and then second E 99. That means 1 times 10 to the 99, so 1 with 99 zeros, but we're making it a negative answer. So it's a very, very small number. It's way to the left in the negative region. Right, so we want minus E99. I'll just wipe that off. So comma 162, comma mean, which is 170, and then comma 8. And close the bracket and enter, and so we get 15.9% are less than 162 centimetres. Okay, so we could have easily done that just by going second distribution, normal CDF, and they actually guide us through with all the questions. So we just go minus second E99 for the lower, the upper is 162, the mean is 170, the standard deviation 8, and we go paste and enter. So that's 15.9% less than 162. So that's how you get the calculator to do exact probabilities. So you can use the calculator to do some of these questions down here. So do 7F2 using your calculator to do question 1 and question 2. Okay, pause the video, come back and see the answers. And here are the answers to 7F2, question 1 and question 2. Okay, in the next video we'll look at standardising this and converting them into Z scores.